Let's say you have some data, like examples of grocery shopping. It has several attributes like fruits, juice bottles, milk, and vegetables. The data also shows you the gender of the buyer. First buyer has bought 1 orange, 2 juice bottles, milk, and beetroot, and that's a female. Likewise, we have 8 such examples. Let's say you have a new buyer. Do you think it's possible to predict the gender? It doesn't make sense, right? But wait, actually we can predict the gender of the person using these attributes. Be with me throughout the video to understand how.
Here we go!
To solve this problem, we can use many classification algorithms like decision tree, random forest, etc. But we are in a deep learning era, so let's discuss how we can use deep learning to solve this problem. Perceptron Learning Algorithm. This algorithm is good at binary classification like yes or no, male or female. Our task is also binary classification, predicting whether it's a male buyer or female buyer. This is our dataset. Our goal is to predict the gender of the person using these attributes. So this is our input and this is our output. When we feed these inputs to our algorithm, it has to predict the correct gender. Before we start off with any deep learning algorithm, we have to clean our data to get a meaningful output. Data preprocessing is an important step in data science. Major steps are handling the missing, noisy, and inconsistent data. We have a problem in our dataset. We have string values and also integer values. We have to transform these attributes into numeric inputs to make it consistent. How shall we do that? For the fruits attributes, let's use XA, XM, and XO as inputs for apple, mango, and orange respectively. This scheme will help us to convert the string to numeric input. For the milk attribute, we can use 1 for S and 0 for no. Let's use this scheme to encode the examples. The values of the attribute juice bottles can directly serve as input xj since they are already numeric. For the goal, gender 1 represents female and 0 represents male. This table setup will help us to transform the examples. Here, CO denotes the correct output. First example, we got orange, 2 juice bottles, milk, beetroot, and the buyer is female. Likewise, we can transform all the remaining 7 examples. Finally, our data is ready to crunch. Let's introduce a weight to each input. This weight determines the contribution of each input towards predicting the output. So let's say this is our input. These are weights. We calculate the weighted sum of the inputs. And then we add a constant called bias. Then we use these values as an input value for the activation function. Activation functions are decision-making units of neural network. They calculate the net output of a neuron. Here, step function is one of the most common activation functions in neural networks for binary classification. Here I've chosen threshold value as 0, so this function produces 0 when the input does not pass the threshold limit and 1 if it does pass through the threshold limit. Finally, the output from the activation function is the predicted output. Using the predicted output, error is calculated. If the error value is 0, that means the predicted value matches with the correct value. If the error value is not 0, then we have to update the weights. We can update the weights using this weight update rule. This table will help us to understand how the algorithm works. Before we move on, these are the values we need to start the calculation. Activation function is a step 0 function. Learning rate 2 and bias value 0 for faster convergence. In the beginning, we initialize all the weights as 1 to give equal importance to all our inputs. This is our dataset. We are going to use the first example. Step 1. Calculating the weighted sum. So we multiply the inputs with its respective weights and add them. The value we get is 5. Step 2. Predicting output. Here the threshold value of our activation function is 0. Now when we pass the value 5, the neuron is activated and we get the predicted output as 1. Step 3. Calculation of error. Error is 0 because the predicted value and the correct output are the same. Step 4. Updating weights. Since the error is 0, there is no need to update the weights. Let's move on to the second example. Again, calculate the weighted sum of inputs. Pass the value to the activation function. Calculate the predicted value. Here, error is -1. Since the predicted value is 1, but the correct output is 0. Now let's use the update rule to calculate the new weights. We substitute the existing weight, learning rate and the inputs to this formula to calculate the new weight. We repeat this calculation until all the weights get updated. So these are our updated weights. Let's move on to the third example. We repeat the same steps, calculating the weighted sum of inputs, predicting the output using the activation function, calculating the error and then updating the weights. We repeat the same steps for 4th, 5th, 6th, 7th and finally the last example. However, error value keeps fluctuating and we haven't achieved convergence. So let's repeat the process again using our first example and we proceed until the weights don't change. Now we have our weights that we need for accurate prediction. But still, let's continue and check with the first 4 examples to see if we get the correct output. Finally, these are the weights that we learned from our Perceptron Learning Algorithm. Using these weights, we can predict the output correctly. Remember, our goal was to predict the gender of a new buyer. Let's say the person buys an apple, 3 juice bottles and a pumpkin. How can we predict the gender? We repeat the same steps using our learned weights and calculate the predicted output. Here we got 1. Based on our scheme, 1 represents a female buyer. Cool! This is the power of a single neuron. It is able to find a pattern in a given data and can be used to solve binary classification of any linearly separable data. Actually, it's just a prediction based on the given data. Prediction accuracy increases if we have more data. So we looked at how a single neuron works. If we use many neurons with many layers interconnected, then it is a deep neural network. That's it. Thanks for watching this video and smash the like button if you understood the concept. Also let me know in the comments if you want to see any specific topic. Naturally, you might have questions like how do we update the weights in deep neural network, how to initialize the weights, how to choose the learning rates, etc. I'll be covering these topics in the upcoming videos, so stay tuned and subscribe. Thank you.